Now that we've explored a little with inequalities, let's go back and deal with a new type of equation. So today we're diving into absolute value equations. All right, and the reason that we're looking at this is these can be broken down into linear pieces. So let's take a look at our first example. So basically what absolute value marks the distance something is from zero. So for example, this absolute value of 5 is 5, and absolute zero of -5 is still 5 because the distance, both of them are from 0, both of them are distance 5 away. Okay? And so because of that, because the positive and the negative are both the same distance from 0, that's why when you're solving something like absolute value of this, you end up breaking it off. X could be 5 or X could be -5 because both are that distance of 5 away. Okay, so that's why you end up breaking apart those absolute values into the two different equations. So let's review how that looks when you're solving more complex equations. So this is going to break up, okay? You're going to get 2x minus 1 equals 5, or that 2x minus 1 could also be -5 because absolute value would make that positive anyway. So you break it up into its positive equation and its negative equation. And now you just solve from there. So add 1, divide by 3, or sorry, divide by 2, add 1, oh, and divide by 2. And those are your two answers. So that's the basis to all absolute value equations, is you get your plus or minus, and then you just solve each of those pieces from there. Now, before you ever split it up, you do always want to make sure that the absolute value is alone, okay? You need to isolate it in the equation. So what that means is here, I need to add that 1 over first, and I need to divide by 3 before I can break this up. Now that the absolute value is by itself, now and only now can I break it up into its two pieces. And now I can solve each piece from here. So subtract 2 would give me 1 for this side and a -5 on that side. All right, now solving these obviously isn't really that difficult, but there's a little caveat that you have to know. So let's think about this equation. Absolute value of 7 equals -7. And I want to find out what x is. So you're probably thinking, oh, easy, x must be 7. So let's think about that though. If I plug in 7 for x, that doesn't work, okay? That fails, it's wrong. 7 doesn't equal -7. Well, they may be thinking, oh, well then obviously -7 must be it. But the absolute value -7 turns it into +7. So once again, that doesn't work. So we run into a dilemma when you have an absolute value being set equal to a negative value, okay? It doesn't end up working. So what we do is we call that a no solution, okay? This is a no solution situation. When you ever have an absolute value set equal to a negative number, you can't do it, okay? We're going to call that no solution. So after exploring a little bit with that, let's do 2 more before we call it good. So here, I'm going to add 7 to both sides, So here, notice, don't be deceived, okay? So that equation originally is that equal to a -2, right? But that doesn't matter. It's you have to check it when the absolute value is isolated. When it's isolated here, you're actually still in good shape. Okay, so don't jump the gun and call that no solution yet, because now when the absolute value is alone, oh, cool, set equal to a positive number so I can keep going. Now I can split this up into its two pieces and solve from there. Add 1, divide by 2. Oh, that's wrong. Add 1, divide by 2. Now, this one is causing issues because the absolute value is alone and it's being set equal to a negative, okay? So this is our situation that we would say that this one has no solution. There's no way we can make that happen, okay? You can never have an absolute value that's set equal to a negative. So that one we're just done, just call it a no solution. So as always, thank you for joining me, and now feel free to move on and you should do the worksheet associated with these notes.